Welcome everyone. I am your favorite physics teacher, TSR, a teacher by choice, not by chance. Today we will be discussing about conservative and non-conservative forces. Forces in this world, they can be classified as per many criteria. Sometimes we classify forces as internal force and external force. Sometimes we classify forces as conservative force and non-conservative force. Sometimes we classify forces as contact forces and field forces, right? Today let's discuss how forces can be classified into conservative and non-conservative forces. So this classification is based on the criteria that whether work done by them depends on the path or doesn't depend on the path. So let's start from here. So hope all of you know how to find out work done by a variable force. So work done by a variable force, its formula is integration F dot ds. So forces, if the force is constant, then we can use the formula work done equal to F dot delta S. But if the force is not constant, if it is a variable force, then we have to use the formula work done equal to integration F dot ds. Or for that matter, this can be written as integration Fx dx plus integration Fy dy plus integration Fz dz. Here we have to put the limits of x, here we have to put the limits of y, and here we have to put the limits of z. So the body is moving from x1, y1, z1 to the point x2, y2, z2. So depending on whether the force is constant or variable, to find work done, we have to use any one of the formulas. Let's say the force is 2 Newton and question is find work done by it. So force is 2 Newton, it's constant force, we have to use this formula. Let's say the force is 5 Newton and then find work done by it. Then 5 Newton, that means the force is constant force, we have to use this formula. But let's say the force is 2x. So when the force is 2x, it's a variable force. So to find work done, we have to use this formula, integration Fx dx, that is integration 2x dx. Let's say the force is xi cap plus yj cap. So this is a variable force. So to find out work done, we have to use the formula integration F dot ds, that is integration x dx plus integration y dy. Hope you are clear about this, how to find work done. So let's find out work done. Let's find out work done by different forces and then see whether we are able to find out the work done without any extra information being given, or do we need some extra information called as the equation of path to be able to find the work done. If we don't need any other extra information to find out work done, if we can just integrate and find out work done, that means that is a conservative force. But if we need some extra information, the equation of path to find work done, then that is a non-conservative force. Let's see. So let's say here is an example. Let's say the force is xi cap plus yj cap, and let's say this force displaces the body from 0, 0 to the point 1, 2. Question is find out work done. Okay, is this a constant force or a variable force? Certainly this is a variable force, isn't it? This force varies from position to position. So to find work done, I have to use integration Fx dx, this is Fx, integration Fx dx plus integration Fy dy, this is Fy, integration Fy dy. Okay, what are the limits? The limits of x from 0 to 1. What are the limits of y? From 0 to 2. Okay, so this comes out to be x square by 2, and this comes out to be y square by 2. So this comes out to be half plus this comes out to be 2, so this comes out to be 5 by 2. So we have found out the work done, and its unit will be joule. Its unit is Newton. So the unit of work is joule. Now to find out the work done, did I need any other extra information other than the force and the initial and final point? No. So this is a conservative force. So this is a conservative force. So conservative force means to find out work done, you don't need any extra information called as equation of path. You just need the force, the initial point and the final point. Now let's see another example of a non-conservative force. You try to find out work done and see whether you will be able to find out the work done or not. So let's say I have another force equal to y I cap plus x square j cap, and let's say the body moves from 0,0 to 1,4. Question is whether this force is conservative force or non-conservative force. Let's say the question is find out work done. Let's see. So we will try to find out the work done. So what will be the formula of work done here? Integration fx dx plus integration fy dy, isn't it? Integration fx dx plus integration fy dy. What is the integration fx dx here? This is fx, y dx. Integration fy dy. What is fy? This one. So integration x square dy. Now here is the misconception. See how students solve and how they get the wrong answer. Now the few steps which I am going to do, you are not supposed to do like this, but students do it like that. That's the misconception. So how students will solve it? They will solve it like this. Integration y dx, so they will write it as y square by 2, and integration x square dy, they will write down this as x cube by 3. This is wrong. This is wrong. Who said integration y dx is y square by 2? All of us know that integration x dx is x square by 2. Integration y dy is y square by 2. But integration y dx, here the variables are different. So this is neither x square by 2 nor y square by 2 nor the average of x square by 2 plus y square by 2. Sometimes what happens when we don't know the answer, right? Somehow we try to be dishonest and write down something there, you know. So honesty is the best policy. See, whenever you are making some mistake, as if someone from within tells you are making a mistake, but when we don't pay any attention to that, then we make mistake. So making mistake is always difficult, because as soon as you are going to make a mistake, you will get a feeling that ऐसा तो होता नहीं है, ऐसा तो मैंने कभी सीखा नहीं, सुना नहीं. हम क्या सोचते हैं, नहीं आता है तो कुछ भी लिख दे, तो कुछ भी लिख दो. ये मूड पे जब हम काम करते हैं तो इसी तरह के आंसर मिलते हैं, right? So we can't solve it like this. Integration y dx, you just can't solve it like this. That means here, from here onwards, the integration will be done. That means we can't find out the work done. So here the force is given, the initial point is given, the final point is given, but we will not be able to find out the work done. We need some extra information here, right? That means this is not conservative force. This is a non-conservative force. Achha, what is that extra information? That extra information is, see, if I give you some relation between y and x, will you be able to solve it? Yes. Let's say this is y-axis, this is x-axis, the points. This is 0,0, and the point here, this is 1,4. Let's say it is given that the body moves like this. That the body moves like this in a straight line, right? So what is the equation of this straight line? What is the equation of this straight line? This is straight line, so the equation should be y equal to mx plus c, isn't it? Y equal to mx plus c. What is m here? 4 by 1. So it is y equal to 4x, isn't it? Now if this extra information is given, how the body is moving? The body is moving along a straight line, and then the equation of the straight line is given. Then using this extra information, now this integration can be solved. See how it can be solved. So this is integration y dx, na? So y, it can be written as how much? It can be written as 4x dx, isn't it? And x square, x square. This can be written as x means y by 4. So this is y square by 16 dy. What are the limits? X का limit 0 to 1, y का limit 0 to 4. Now this is 4x dx integration. So this becomes x का integration, x square by 2. So this is 2x square, limit from 0 to 1. And this is y square का integration, it is y cube by 3. So y cube by 48, limit from 0 to 4. So this comes out to be 2, and this comes out to be, put here 4 cube. So this comes out to be 4 into 4 into 4. So 4 into 4, 16 into 4. That is 64 by 48. So this is 2 plus 4 by 3. So this comes out to be 10 by 3. So here you see example of a force whose work cannot be found if you don't know the equation of the path. Then you just can't solve from here onwards, right? So this is a non-conservative force. Now another property of the non-conservative force is that the first one I have discussed now. Unless the equation of path is given, you won't be able to find out work done. The other property is that if I change the path, let's say the body is not moving along the straight line, but let's say the body is moving along another path. Let's say the body is moving along this path, along this parabolic path, y equal to x square. Then you try to find out the work done using this extra information, not this. Then the work done will come out to be something else. So non-conservative forces are those for which work done cannot be found if the path is not given. And if the path is given, then the work done is different for different paths. So for this path, straight line path, work done will be different. You have to use this extra information to solve it. And for this blue line path, the parabolic path, work done will be something else. That as a homework you can find out yourself and you can see what's the answer, right? So this is non-conservative force. So these were mathematically constructs that this force is conservative. And the previous example which I had taken, let's say F equal to x I cap plus y square j cap, this is conservative force, right? So here I have given two examples, one of conservative force and the other of non-conservative force. These are mathematical constructs. You can construct mathematically any force, but actually in nature, the forces which exist, we can classify them as conservative and non-conservative forces. So there are three conservative forces in nature. We have got electrostatic force, gravitational force, and spring force. Similarly, there are non-conservative forces like friction, air resistance, and viscous force. What else? What are the other properties of conservative and non-conservative forces? So this is very important theory. So let me explain. So conservative forces means, let me take two examples to make you understand the difference between conservative force and non-conservative force. Let's say I have a body, and let's say I throw it vertically upwards with some kinetic energy, let's say 10 joule. So if I throw the body having kinetic energy 10 joule vertically upwards, so it will move up, and as it moves up, it will slow down because gravitational force is acting downwards. So because gravitational force is acting downwards opposite to the motion of the body, so the gravitational force slows down the body, and at topmost point its velocity becomes 0. That means its kinetic energy goes on decreasing. Its kinetic energy goes on decreasing because of this gravitational force, because of this conservative force. But it is not a permanent decrease, or it is not a permanent loss of kinetic energy. When it is moving up, the kinetic energy is decreasing, but after some time, when it comes down, it will regain its lost kinetic energy. So when conservative force like gravitational force, electrostatic force, spring force, they decrease the kinetic energy of a body, they slow down a body, the loss of kinetic energy is not permanent loss. It is converted to some form which is called as potential energy. And after some time, the body regains its kinetic energy, right? Think about non-conservative forces. Let's say the same body, I throw it on ground. I throw it on ground. Take a body and then slide it on ground, giving it a kinetic energy of 10 joule. What do you think will happen? It will slow down. Because of which force? Because of friction. So now the body slides down, and because of friction it slows down. So again, here also the body is slowing down, the kinetic energy is getting lost, but this is permanent lost. The body slows down and comes to rest. Then it's not going to regain its kinetic energy and come back to you, isn't it? Like here, if you throw, it goes up and then comes down. It loses kinetic energy and it gains kinetic energy. But here on ground, you throw it loses kinetic energy and then it stops. So the loss of kinetic energy is permanent loss. So here the kinetic energy gets lost. That means from kinetic energy it gets transformed into heat energy, right? You don't get the kinetic energy back. So we get, in nature we have got these two kind of forces, conservative and non-conservative forces. So conservative forces means when they slow down a body, the loss of kinetic energy is not permanent loss, it's temporary loss. So we tell that the kinetic energy gets converted into potential energy. But when there are non-conservative forces and the non-conservative forces slow down a body, the loss of kinetic energy is permanent loss. The kinetic energy gets converted into heat energy. So in this world, we have got two kinds of forces, conservative and non-conservative. Mathematically, you can see it here. Hope this satisfies you. Let's stop here.